Good afternoon, class. We are looking at Module 1, covering chapters 1 and 2 of pre-calculus practice test. Here's chapter 2, linear functions. Chapter 2, linear functions. Dependent and independent variables for an equation in variable x and y. If the value of y depends on the value of x, then y is the dependent variable and x is the independent variable. So when you have a piece of graph, if you lay it down along the x-axis, gives you the domain, along the y-axis is the range. Relation is a set of ordered pairs. Domain, the set of all input values, x values are independent variable for relation. Range, the set of all output values, y value dependent variable for a relation. A function is a relation in which each element in the domain corresponds to exactly one element in the range. Vertical line test, or VLT for short. If a vertical line can be drawn so that it intersects a graph at more than one point, then the graph does not represent a function. If a vertical line cannot be drawn so that it intersects the graph at more than one point, then the graph represents a function. A function is one-to-one if each element in the range corresponds to exactly one element in the domain. Horizontal line test, if a horizontal line can be drawn so that it intersects the graph of a function at more than one point, the graph is not one-to-one. In other words, in the case of a function, the x coordinate cannot repeat. In the case of a one-to-one function, the y coordinate cannot repeat either. Find the domain of each function. To do so, in the case of a rational function, you set the denominator equal to 0. You get 1/2, and you exclude that. So domain is all x except 1/2. So you can write it in this format, but in an interval format from -infinity to 1/2, union 1/2 to infinity. A square root. When the index is even, what's underneath must be non-negative. So 5x plus 4 is greater than or equal to 0. Divide by 5. So x is greater than or equal to -4/5, or and then in an interval notation, -4/5 to infinity. This is a polynomial of degree 2 or a quadratic function. Therefore, the domain is all real numbers. Quadratic function. Cube root of x has no restriction. Whenever the index is odd, the domain is all real numbers. You set the denominator equal to 0 because it's a rational function, and you exclude it. That means x squared is 1, x is plus minus 1. You excluded. This is the domain, everybody. How do you write it? In an interval format. From -infinity to -1, union -1 to 1, union 1 to infinity, and all of these endpoints take parentheses, meaning the endpoints are not included. In this case, the domain is all real numbers because it's a linear function. Determine if the graph represents a function, a one-to-one function, and find the domain and range of each using interval notation. This one represents a function as well as a one-to-one function because it passes both VLT and HLT. There is no vertical line that crosses more than once. There is no horizontal line. Therefore, the domain is from 2 to infinity. 2 is not included. So from the parentheses 2 to infinity. And the range from here, 6 is included, 8 is not. So 2 to infinity, 2 is not included because there is a hole here. And then range from from 6 to 8, 6 is included, 8 is not. Is this a function? Yes. Is this a one-to-one function? No, because it fails the horizontal line test, right? For example, right here. So what is the domain? The domain, if you lay it down along the x-axis, starts from here, goes to here, from -3 to 2. -3 is included, 2 is not. What is the range? Goes from here to here. And the endpoints are both included. This one is neither a function nor a one-to-one function. It fails a vertical line test. If it fails a horizontal line test, the domain 1, 2, 3, 4. So it's -4 to 0. 1, 2, 3, 4 from 0 to 4. F of x is 2x plus 1. Find and simplify. F of x plus h minus f of x over h is known as the difference quotient. And reminding you, when we have a curve, we connect 2 points, it creates a secant line. Rates of change. The difference quotient, delta y over delta x equals f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1 is called the average rate of change of y, or f of x with respect to x, over the interval of x sub 1 to x sub 2, and can be interpreted as the slope of a secant line. Now, as you can see here, x sub 1 and x sub 2 gives you this formula. But if you go with this one, with this distance, we can use a or x here. So we should be able to evaluate this. It's important for the next course. And so we want f of x. So if it's b, and f of b, of course, becomes those formulas. Okay. There are many formulas, we've discussed them, but pay attention to this one for this one, okay? So f of x plus h, 2 times x plus h plus 1, minus f of x to x plus 1. So we are going to distribute, we get 2x plus h plus 1 minus 2x minus 1 in the numerator, and these two cancel each other. These two cancel each other. 2h over h is 2. Even f of x equals to x squared plus 1, and g of x equals 3x minus 5, find the following, f of g of 2. Well, first and foremost, we have to find g of 2. 3 times 2 minus 5. Let me remind you of algebra functions. All of these are algebra functions. F plus minus g is f of x plus minus g of x. F times g is f of x times g of x, and so on. Composite function f of g is g f of g of x. G of f is g of f of x. So first evaluate g of 2. 3 times 2 minus 5 makes it 1. Now you want f of g of 2, which is f of 1. So now plug in 1. 2 times 1 squared plus 1, which is 3. F of g of x, known as f of g of x. So you replace the x with 3x minus 5. So what do we have here? A minus b quantity squared is a squared minus 2ab plus b squared. So you square this one, get 9x squared. And the product of these two times 2 makes it minus 30x. And then this one squared is 25. Following that. So 2 times 9x squared, 18x squared. 2 times negative 30, negative 60x. 2 times 25, 50 plus 1, 51. So in essence, we multiply 2 by 25 and we add the 1. The rest is not being combined. We want to continue on that thoughts, and we want to find g or f of x. By definition means g of f of x. So replace the x with f of x. 3 times 2x squared plus 1 minus 5. So this is 6x squared plus 3. 3 and negative 5, negative 2. GOG, that means replace the x with the g itself, 3x minus 5. So this is 9x minus 15. These two add up to negative 20. We continue on that thoughts. We want f of negative 2. Which means we want f of negative 2. That's the meaning of it. Which means we have to evaluate the function f of x at negative 2 first. So f of negative 2 is 2 times negative 2 squared plus 1. This is 4 times 2, 8 plus 1 is 9. So we want f of 9. Nine squared is 81 times 2 plus 1 is 163. Determine if the functions f of x and g of x are odd or even. And let's remind everybody, odd means f of minus x is minus f of x, and even means f of minus x equals f of x. So even function f of minus x is f of x, which makes it symmetric with respect to the y-axis. Odd function f of minus x is minus f of x, which makes it symmetric with respect to the origin. So f of minus x, 2 times minus x quantity squared plus 1. I hope you recognize this is the same as x squared. So 2x squared plus 1, which is identical to f of x. It makes it an even function. G of minus x, replace the x with negative x. So this is negative 3x minus 5. Now, is this the same as g of x? No. Is this the opposite of g of x? No. So it's neither nor. It's neither even nor odd. Find the average rate of change of each function on the specified interval. F of x equals 3x. We want to go from -1 to 1. And again, reminding you of this, you remember we've looked at this concept before. So please understand this is not a pair. We're going to go from x equals -1 to x equals 1. So we want f of 1 minus f of -1 over 1 minus -1. In other words, look at this one. It makes it easier if we look at this one. So this is x up 1, this is x up 2. So what is f of 1? 3 times 1. What is f of -1? 3 times -1. Times 1. So we have 6 halves or 3. F of x is 2x minus 9, which means again 6 of 1 is x of 2, and we are going to use this one. So f of a minus f of 4 over a minus 4. So if you replace this with a, you get 2a minus 9. If you replace it with 4, you get 2 times 4 minus 9. So we have 2a minus 9 minus -1. That means plus 1, 2a minus 8. You can factor the 2 from the numerator, factor out the 2, and the final answer is 2. F of x is 3x plus 4. We're going to go from 2 to 2 plus h. So we are going to plug in 2 plus h. F of 2 plus h minus f of 2 over 2 plus h minus 2. So f of 2 plus h, that means 3 times 2 plus h plus 4 minus f of 2 means 3 times 2 plus 4, and the bottom is simply h. All you have to do is simplify the numerator. and everything cancels out in the numerator except 3h. Divided by h gives you 3, and we are done. So it's pretty straightforward, everybody. We are going to move on. Graphing techniques, transformations, reminding everyone. In short, vertical and horizontal shift translation. We are assuming C is positive. So what happens is, if you have a function f of x plus c shifts up by c units, f of x minus c shifts down by c units, f of x minus c goes to the right by c units, f of x plus c goes to the left by c. If you have f of x and you multiply it by c being larger than 1, it stretches by a factor of c. If you divide it by c, it shrinks by a factor of c. And if you go with negative f of x flips over with respect to x. If you go with f of minus x flips over with respect to y. That's the idea about transformations. Now the following function was graphed applying transformation to a toolkit. When we say toolkit function, essential function, basic function, you're supposed to know a bunch of them just for the sake of argument. F of x equals b is a constant, f of x equals x, or y equals x. Y equals x, or f of x equals x squared, or x cubed, or squared over x, or cubed root of x. You should know all those functions, their graphs. And when you know that, take a look. This is the constant function. When you know that, you know the domain is all real numbers, and the range is only b. And you know that the domain and range is all real number. When you know that domain is all real numbers, range from 0 to infinity. When you know the graph, domain and range are real numbers. This one domain and range from 0 to infinity. This one domain and range are real numbers. So knowing the graph, a rough sketch, doesn't have to be perfect. It helps us with transformation and understanding the general shape. So definitely this is a V shape. And an absolute value function is in this format. We know that, where here's the vertex. And so the new vertex is located at 3, -2. So it really means it's been shifted to the right by 3, coming down by 2. And so this, in essence, becomes absolute value of x minus 3 and then -2 outside. But anyways, if we want to go with the general format, y equals a times absolute value of x minus h plus k, if we want to go with that. We're going to replace the h with 3 and k with -2. All you have to do, pick a point and do the math. Easy points. This one has coordinates 1, 0. You can use that. And this one has coordinates 0, 1. You can use that. It doesn't matter which one you use one more point and you get the A. So if I use 1, 0, that means I replace the y with 0 and x with 1. So 1 minus 3 is -2, but the absolute value makes it +2. So again, let me just write that. This is -2. The absolute value makes it +2. So we have 2a minus 2, everybody. And so a becomes 1. And that's a graph. Now, here's what you should do. When you find the final answer, you pick another point, maybe this one, and check it, or some other point, any other point, maybe a couple points to be on the safe side that you do have the correct answer. You want to make sure that it's the correct answer, everybody. The following function was graphed by applying transformation to a toolkit function, essential function, such as one of those. Write the equation of a function that matches each graph. And so because we know the shape of graphs, we remember y or f of x equals square root of x looks like that. So it's similar to that. And of course, this has the intercept of 0, 0, and it has shifted to this point, -3, -1. So k square root of x plus k, and that's a general format, if you will. -3, remember, shifts to the left, so you have to put x plus 3 minus 1, shifts down, you have to put -1 here. And now you can plug in one of the points. What is the easy point? We can clearly see this one having coordinates -2, 0. Again, you want to make sure you pick a point that it's easy to recognize. So now we are going to plug in. That means we're going to replace the x with -2 and y with 0. Of course, this is 1, comes out as 1. So a minus 1 is 0. That means a equals 1. So we plug in, and we get y equals square root of x plus 3 minus 1. And one way to check it, you can put, for example, this point which has coordinates 1, 1 in it to make sure it checks, and it does. So after you find the answer, you have to check. The following function was graphed by applying transformation to a toolkit function, such as one of those, etc. Write the equation of a function that matches each graph. So clearly, we know this parabola y equals x squared or f of x equals x squared. So there has been some sort of a transformation to get this. So obviously the vertex is 0, 0, but this one is located at -1, +2. And y equals a times x minus h quantity squared plus k. And so x minus -1 makes it +1, plus k makes it 2. And All you have to do, pick one more point, any point, and check. This is an easy point because it has coordinates 0, 1, right? You don't have to pick that point, but that seems to be one of the easiest ones. So replace the x with 0, y with 1. This is 1, squared is 1, a plus 2 is 1. So let me just do this. This whole thing becomes 1. A plus 2 is 1, a is negative 1. And when we plug in, that means into this, replace the a, y equals minus the parenthesis x plus 1 quantity squared plus 2. As you know, parabola opens down, a must be negative, and you can find maybe another point which is easy to find. For example, this one seems to be -3, -2, and make sure that works, and it does. So easy points, the points that are for sure, because they are not nice and easy points, we may make a mistake, okay? Find the equation of a function that is finally graphed after the following transformations are applied to y equals x squared. So shift right 3 units. So x minus 3 squared. So f of x is x minus 3 squared, or g of x or h of x, give it any name you want. Reflect about the x-axis. So you put a negative sign in front of it. Shift down 2 units, subtract 2, or add -2, however you want to put that. Reminding you of extreme or local or relative extreme value is a plural of the Latin extremum. A local minimum is the minimum value within some open interval. Local minimum occurs at a point C in an open interval of A to B in the domain where f of c is less than or equal to f of x for all x values in the open interval. A local max is the maximum value within some open interval. Local max occurs at a point C in an open interval of A to B in the domain f of c if f of c is greater than or equal to f of x for all x values in the open interval. So local mean, local max, local mean, local max, peaks and valleys. Absolute or global extreme values or extreme are either maximum or minimum points on a graph. Absolute minimum occurs at the point C if f of c is less than or equal to f of x for all x values, not in some open interval, for all. Absolute maximum occurs at the point C if f of c is greater than or equal to f of x for all x values in the domain. And so what I want you to see is very simple. Local mean, local max, local mean. This local mean is also absolute mean. Local max, local mean, local max. Peaks and valleys are local. This happened to be an absolute because no other point has a larger var coordinate. Extreme value theorem indicates if f is a continuous function whose domain is a closed interval of A to B, and then f has an absolute max and absolute mean on the interval of A to B. That's called closed interval theorem. Use the graph to estimate the intervals where the function is increasing or decreasing. So let's remind everybody, a function f is increasing on an open interval if for any choice of x sub 1 and x sub 2 in the interval x sub 1 less than x sub 2, f of x sub 1 is also less than f of x sub 2. Decreasing is the opposite of that. If x sub 1 is less than x sub 2, f of x sub 1 is larger than f of x sub 2. In other words, In this case, x gets larger, y gets larger. In this case, when x gets larger, y gets smaller. That's the simplest way to think about it. And of course, a function is constant at an interval I if for all choices of x in the interval I, the values of f of x are equal. So we want to estimate the intervals where the function is increasing and decreasing. I hope you see increasing, decreasing, increasing. So just think about the line. Assume this is a line. Looks like a line with a positive slope. Line with a negative slope, line with a positive slope. So it's increasing from here, minus infinity to -3. This is -3. And then union 3 to 7. Decreasing otherwise in between. And x is between -3 and 3 or -3 and 3. And by the way, we don't use brackets because the endpoints we don't know. Again, just use a color. This portion of the graph is decreasing a little bit. Okay, the rest is increasing. A note in mom, increasing may take the bracket, okay, and decreasing may take the bracket. But stick with parentheses. Even if they use brackets, let me know and I will give you full credit. But they shouldn't use brackets. Determine any local maximum or minimum values. Well, this one, let me erase so we can see where it's located. This one has a y coordinate of 50. So the local max is equal to 50, has an x coordinate of -3. We say local max equals 50. We say either at x equals -3 or the pair -3 comma 50. This one is a local mean. And the coordinates are +3, -50. So local minimum is equal to -50. We say either at x equals 3 or the pair 3 comma -50. Determine any absolute max or min. Peaks and valleys could be absolute if they are, but they are local in this case. The endpoints are not local. They can be absolute. As you can see, this is absolute max. This is absolute min. So absolute max has the value of y coordinate being 150. So 150 at x equals 7. So we say absolute max is 150 at x equals 7 or 7 comma 150. What about absolute mean? This point has an absolute mean value of, let's see, there seems to be like 225, whatever you read. If you read 230, I'm okay with that. But the x coordinate is close to -8. So we're going to read absolute minimum is -225 at x equals -8 or -8 comma -225. All right, it's time to move on to the next question. For the following function, find f inverse of x. And as you recall, f inverse of x, first thing first, we change f of x to y because it makes it easier to work with. The second step is to interchange x and y. And in this step, we do have the inverse. However, we solve for y. So x plus 7 is 2y. Divide by 2. And that's y. We are going to change the name to F inverse. And as always, you have to prove you have come up with the correct answer by either finding F of F inverse or F inverse, or if it's your choice, but you have to find one of it. So if we go with one of these, for example, F of F inverse of X, that means this is F of X, replace the X with F inverse, which is X plus 7 over 2. We get X plus 7 minus 7, which is X. That's a proof. And one of them is really good enough. All right, we're going to continue finding F inverse. In this case, again, we change F of X to Y. We interchange X and Y. This becomes X, this becomes Y. And now, again, right here we have the inverse. However, we are going to solve for Y, which means we are going to put over 1, and we do the cross product. So when we do the cross product, this is X times Y, this is plus 2X, this is equals Y. You're solving for Y. You move this, and you factor the Y out from the right side. Divide by 1 minus X. This is the inverse. Call it F inverse. Now, one thing I want to make a point of, why am I writing them two ways? Because the way you move things around here, if you had moved the Y over there and 2X here, you would have gotten this one. You would get minus 2X over minus 1 plus X, or X minus 1. So please understand, these two are identical. If you multiply the top and the bottom by negative, you get this one. So I'm giving you both so you see there is no difference between the two. So to find F of F inverse, so we want to find F of F inverse of X. To prove we've come up with the correct answer. And by the way, you have to come up with one of those. So this is F of X, F of F inverse. You replace the X with either the green one or the red one. So X is 2X over 1 minus X, same thing here. And this is a complex fraction. To simplify the complex fraction, we multiply the top and the bottom by LCD, which is 1 minus X. So when I multiply these two, the numerator gives me only 2X. When I multiply these two, this gives me 2X plus 2 times 1 minus X. So I hope everybody is comfortable with complex fractions. So all I have to do is simplify the bottom. By distributing this one, I get 2 minus 2X. And 2X over 2 equals X. And that's a proof we've come up with the correct answer. Use function composition to verify f of x and g of x are inverse functions. So you look at the composite function, f of, remember, f of f inverse of x equals x is the property we know. So we're going to go with f of g of x and show that it's x. Which means if I want f of g, I'm going to replace the x with x cubed plus 1. So f of g of x is cube root of x cubed plus 1 minus 1. A cube root of x cubed equals x, and that's a proof, and we are done. You don't have to show GOF, that's good enough, but just for the sake of practice, if we put GOF, that means instead of x, put cube root of x minus 1. This is being raised to the power of 3, so it becomes x minus 1. 1 and negative 1 cancel each other, we get x. Sketch the inverse of the function whose graph is shown. We can draw the line y equals x and reflect the graph on the line, meaning just pick up a few pairs and then find the inverse. For example, and always go with easy points. For example, this point has coordinates -2, -4. So -2 comma -4 is part of the f of x function. So that means -4 minus 2 belongs to f inverse. To discuss it with details, we write f of -2 is -4. That's the meaning of it, right? By the way, this is read an element of, we've discussed that before. So that means f inverse of -4 is -2, and therefore -4, -2 is an element of f inverse. You can go from here to here. Okay. Let's pick another easy one. So for this point, we get this one. Another easy point would be the y-intercept located at 0, 4. 0, 4 belongs to f of x. So if we want to go directly to the end, we write 4, 0. This one belongs to its inverse. Or we write f of 0 is 4. That means f inverse of 4 is 0. And that means 4, 0 belongs to f inverse. That's the other point. Another easy one, -1, +3 belongs to f of x. If we want to go just to the end, we would change this to 3 minus 1. But to show this here, we say f of -1 is 3. So f inverse of 3 is -1, and therefore 3 -1 belong to f inverse, which is this point. And looking like that. By the way, if there is a point of intersection, because x and y are interchanged, and the x on one is equal to y on the other, if they intersect, has to be on the line y equals x. And that's the graph of the inverse. I'm going to sketch the graph of this function. We've already gone through that so quickly. If you want to graph a piecewise defined function, first, don't pay attention to that and graph the 3 parts. One part is y equals minus x plus 1. One part is this, which is the pair 1, 2, and one part is y equals x squared. So, by the way, if you were to pick up some pairs, for example, so you know how that works, -1. Remember, when x is between -1 and 1, we can go with that one. Because it has the equality, we're going to put it here, -1. Negative times -1 is +1, and 1, this is 2. If I want 0, again, I go here and I find 1. If I want 1, it's precisely 2. It's this pair. If I want larger than 1, I got to go to the second piece, to the last piece. If I want 2, I have to put it here, I get 4. If I want 3, I have to put it here, I get 9. So those are the pairs, if you wanted to go with the pairs. But never mind that. Let's graph y equals minus x plus 1, the top piece. And I'm assuming nobody has any problem with intercepts, so 0, 1, 1, 0, and the graph looks like this. The pair 1, comma 2 is here. Again, we are not paying any attention to this. Just ignore that. Ignore that completely for now. And the last piece, y equals x squared. Okay, parabola looks like that. Now that we have 3 pieces done, we are going to put them together as follows. This is good. The line is good from -1 to 1. And please understand, this is -1, this is 1. So from -1 to 1, and at 1, we don't have the equality, it's not good. At 1, we get this point. So this portion of the line is the only portion we need. Y equals x squared, x is larger than 1. Okay, so this is 1, this point is 1, 1, but at 1, it's not equal to that after that. So we get a hole, and up there, this is the portion. Now put this one, and the point together, you have this graph. Now, if you want to find the domain, you look at the graph, it starts from here, which is from -1, and goes to infinity. If we want the range starts from here and goes to infinity. But over here, I see a hole. So this one is not covered. So from 0 to infinity, but 0 is not covered. Whereas here, -1, we have a solid point and it's covered. F of x is x squared minus 3x, and we want to find the average rate of change from x equals 2 to 4. That means basically f of b minus f of a over b minus a, or f of x up 2 minus f of x up 1 over x up 2 minus x up 1. So f of 4 minus f of 2 over 4 minus 2. You plug in 4, you get 4 squared minus 3 times 4. You plug in 2, you get 2 squared minus 3 times 2. And the numerator is 4 minus 2, or 2. 16 minus 12, 4 minus 6 minus 2. That makes it plus. So 16 minus 12 is 4 plus 2, 6 halves, or 3. Now from 4 to 4 plus h. We want f of 4 plus h minus f of 4 over 4 plus h minus h. These two cancel each other, of course. And we're going to put 4 plus h, which we get 4 plus h squared minus 3 times 4 plus h. And then the 4, we've already done that. 16, this part, 4 squared minus 16 minus 12. This is 4 from here. You can use that, or just expand it in any event. So this is 16. This is 8h plus h squared minus 12 minus 3h. This is 16. You can say minus 16. This is minus 12. You can say plus 12. The reason it may be easier to do it this way, it's because 16 minus 16. Negative 12, positive 12. So we have h squared, and then these two, 5h. Factor out the h from the numerator, drop the h, and the final answer is h plus 5. Find the value of x if a linear function goes through the following points and the following slope. Well, m is rise over run. So y sub 2. So we have the formulas. Everybody remembers various forms of lines. And again, we've discussed that before. So vertical line, horizontal line, parallel lines, perpendicular lines. So rise over run.
That's gonna drive me crazy.
So y sub 2 minus y sub 1 equals over x sub 2 minus x sub 1 equals slope. The slope is given as 3. And y sub 2, 6 minus y sub 1 is 2 over minus 4 minus x. So you do the cross product, you can find the x. To do the cross product, we are going to do this. So 3 times negative 4 minus x, 1 times 6 minus 2, and of course 6 minus 2, we know it's 4. We get negative 12 minus 3x. We add 12, we get 16. Divide by negative 3, we get negative 16 thirds. We are done. Consider the scenario. A town has an initial population of 75,000. It grows at a constant rate of 2,500 per year. Find the linear function that models the town's population P as a function of the year T, where T is the number of years since the model began. So it's very simple to see P of T is the population as a function of time T, which basically gives you 2,500 per year, 2,500 T, the initial value plus 75,000. But just to elaborate on that, the constant rate of growth, M, is 2,500 per year. The initial is 75,000, which represents B. The linear function in this case, y equals mx plus b, becomes p equals mt plus b. 2,500 t plus 75,000. What would be the population in 10 years? Replace the t with 10. This is 25,000 with 75 becomes 100,000. That would be the population. Monthly cost of a cellular plan depends on the number of minutes used and a flat fee. 410 minutes for $71.50, 720 minutes for $118. Express the cost C as a linear function of the monthly minutes used. Now, monthly minutes would be X. So minutes and cost, that means X comma C. It's important to know your pair. Normally it's X and Y, not the case here. And so what we are dealing with is the pair 410, 71.50, 720, $118. So those are the pairs according to X comma C, because cost is a function of X number of minutes. We normally use y sub 2 minus y sub 1 over x sub 2 minus x sub 1. The denominator doesn't change, but this one we're going to say c sub 2 minus c sub 1. And so 118 minus 71.50, 720 minus 410, and 720 minus 410 is the denominator, 118 minus 71.50 is the numerator. And this becomes 3 over 20 or 0.15. Y minus y1 equals m times x sub 1, m times x minus x sub 1. And so everything remains, and what we change is the y. We are going to say c minus c sub 1 is m times x minus x sub 1. And we can use one of those pairs. It doesn't matter which one. For example, c minus 118 is 3 over 20 or 0.15 times x minus 720. You multiply these two, you get 108. You are going to move this and you get 3/20th of x plus 10 or 0.15x. What is the cost using 687 minutes? Replace the x. Put it into a calculator. And for money, we go for about 2 decimals, so $113.05. Interpret the slope and c-intercept. The c-intercept represents the fixed monthly cost or flat fee charged by a company, which is $10, regardless. The slope represents the change in cost per minute of call for the amount of $0.15 per minute, or 15 cents per minute, or 3/20 per minute. Here's the last question. The height in inches of a sunflower X weeks after being planted can be approximated by the following function. How tall is the sunflower 8 weeks after planting? Replace the expedite. This is 48. 64 divided by 4, 16, subtracted from 48, 32 inches. Find the average rate of growth from the end of week 6 to the end of week 12, include proper units. That means f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. So f of 12 minus f of 6 over 12 minus 6. So plug in 12. 6 times 12 minus 1/4 times 12 squared. And plug in 6. 6 times 6 minus 1/4 of 6 squared. And this is 72. This is 144 times 1/4 is 36. And this is 36. This is 36. 1/4 of it is 9. And I hope you see that this is actually minus 36 plus 9. So these two can cancel each other, right? 72 minus 36 minus 36, they cancel each other. 9 over 6, which is 3/2 of an inch per week. The units of the numerator, okay, which is in inches, over the units of the denominator, which is in weeks.